sine x. Okay, so d over dx just means the derivative of whatever's beside it, right? So anything that starts with a c, the derivative is negative. Anything that does not start with a c, the derivative is positive. You're welcome. Oh, some people. Just kidding. D over dx sine x. Does sine start with a c? This is not a hard question. No. So our derivative is going to be positive. And the derivative of sine x is cos x. Thanks for the positive reinforcement. Okay, d over dx is sine x is cos x. D over dx of cos x equals, what do you think it might be? At the very least, negative sine x. And then it starts getting harder. Okay, so the derivative of sine x is cos x. The derivative of cos x is negative sine x. The derivative of tan x secant squared x. Okay, so cosecant and cotan we know will be what? At the very least. Negative, because they start with c's. The derivative of cosecant x is cosecant x cotan x. And then this one is secant x tan x. And then this one is cosecant squared x. So why does this pop into chain rule? Well, determine the derivative of determined. Good job, Lepp. The derivative of before we do chain rule, we're going to do one easier one. I want sine x tan x. Do you think they're going to put them in brackets like that to remind you that's product rule? Or are they probably going to write it like this? Like that. Which you have to realize is product rule. Okay? FG, go. We have F prime is cos x. G prime is secant squared x. So y prime equals g f prime plus f g prime. And if you can reduce them, you do. This tan x you can reduce. Tan x is sine x over cos x. And then you can take a sine x out of both terms, right? And you could replace it with this if they have that. I'm not going to, but if the textbook doesn't have the answer we're going to have, you could replace the secant squared with 1 plus tan squared root and then change it out that way. I will give you guys the formula sheet from 30-1 on a test, but AP gives you no formula sheet. Right? Remember I told you, like, you asked me, hey, is that formula on the formula sheet? I'll say, what formula sheet? Because There ain't one. All right? But I will let you have that one. You're welcome. Look how I've never given you nothing. You know? All right. What if I give you this? Why does this fit in chain rule? So B, what if I just give you basic tan 4x? So all those derivatives are derivatives of like tan x, secant x, cotan x, right? They're not of the 4x. This is a chain rule question. Remember chain rule, you work from outside in and you get chains, little chains like bracket chains behind it. So this one, we work from outside in. So what's the derivative of tan? Secant squared x. What is my x? 4x. So I did the outside. What have I not? By the time you're done your derivative, you have to derive everything, okay? Currently, what have I not derived yet? The 4x. What's the derivative of 4x? 4. So that goes behind in a chain. And then they'll often write it first. So a lot of people will change this right away and get rid of that. You can't. You write it, the outside with the inside still there, and the derivative of the inside, right? Okay, this is one where people not so great at because they don't know what to do with it. So what if I give you cosecant 4x this time? What's the derivative of cosecant? Negative cosecant cotan, right? So it's going to be negative cosecant 4x cotan 4x. Then people want to tell me that they chain behind it 2 4s. But we didn't have 2 4s, right? It's just the derivative of that has 2 4s. So we have to do the derivative of the inside of this one. What's the derivative of the inside of this one? 4. So I just get a 4. Do you see how you could oopsie and try and put 2 4s there? People do it all the time on my tests. You don't want that. Okay? So those ones like cosecant and secant, those are the ones that throw people off because cosecant is negative cosecant cotan, so it comes out with 2. And secant is secant x tan x, so it comes out with 2. So those are the ones that people mess up. The rest are all singles, so it's not as bad. Do you understand, though, with those two, you still need to take the derivative of that one. So we get y prime equals negative 4 cosecant 4x cotan 4x. So trig derivatives aren't too hard alone if we just had just a trig derivative, but they're often embedded in some sort of power rule with something else. Okay? Okay. D. F of x equals x squared plus 3x to the 4 tan 5x squared. Actually, I'll just do 5x for now. I'm not going to, I'll do the extra hard. So the people who do really bad on the unit test will just do the derivative of the first one, derivative of the second one, and call it a day. You have to spot that this is a what? Product rule. So I will always go and put a dot in here. And this is F, G. Okay? All right. So we have a really large red marker. That's what we have. Okay, F prime of x. So F prime is a chain rule. 4x squared plus 3x to the 3, 2x plus 3 behind it. Right? When we have a chain rule, we know we're going to be able to GCF something out. Yes? That's the point of the chain rule. Except for trig, that doesn't know. So tan 5x is secant squared 5x times 5. And a lot of you, after doing this enough, we'll just write it as 5 secant squared 5x without doing this second step in here. All right. So we get G. And like I told you, in the textbook, it will say FG prime plus GF prime, right? It will. But then it's the opposite of the quotient rule and just causes confusion. So when you go to look at your answer key in any textbook, remember that your terms will be opposite, right? A lot of the time, if they actually have the worked out solutions, they'll have whatever you have second first and whatever you have first second, as we do GF prime. Okay, G, F prime. Plus F, G prime. The two terms. Now you see what can we take out of them. So I have a 4, I have a 5. Can't do anything with that. I have a tan, I have a secant. Can't do anything with that, as is 2x plus 3 randomly sitting here. But I can take out an x squared plus 3x to the 3. So then we're left with 4, 2x plus 3 times tan 5x plus 5 secant squared 5x. And then we get x squared plus 3x to the 3. What did I forget about?
X squared plus 3x.
On this one. Good catch. All right. So I get 8x plus 12 times tan 5x. Plus 5x squared secant squared 5x. And then 15x secant squared 5x. And then I get x squared plus 3x cubed, 8x tan 5x. Plus 12 tan 5x plus 5x squared secant squared 5x. That's 15x secant squared 5x. Can I take anything out of each of those terms? I have an 8, a 12, a 5, and a 15. Nope. I have an x, a no x, an x squared, and an x. What?
Couldn't you take a 1 over cos x out of 10x and secant squared x?
Like to take it out and then put it in the front?
Yeah.
Sure. If they've got it to that point, you could take a tan and make it tan over cos. Take secant 1 over cos, take out a 1 over cos, and then you'd be left with a cos and a sine. You could, yeah. The thing, remember with trig proofs, where it was like trig proofs aren't hard, but trying to get them to, no, sorry, not trig proofs. If they work the trig proof halfway down, or even logs aren't hard, but when you try and make it match the log that they have, you're like, what did they do? Like I've solved this is lovely, but doesn't match their answers at all. That's sometimes the back of the textbook. Like you're like, oh, I think I did it right, and then they'll have pulled a 1 over cos out, and then they have a sine, a cos, right? And then like, how do they do that? Or they switch a secant squared to a 1 minus tan squared. So this is good. Taking out 1 over cos would be good. You just to match their answers. I think most profs would just be fine with this. All right. So that's all of chain rule. Really, we have implicit left. Implicit is when you have x and y derivatives together. So you have to do that. And then we have related rates we still have to do. And then I can ask you, guys, I can ask you for any tangent or normal line with any derivative, correct? As long as I give you a point or an x or a y value off of it. Same thing. This is first derivative, but this is also general tangent slope. So then I could plug something in for x and get the actual slope on that graph as well, right? So any derivative I can ask for that. It's nothing crazy. We still have log derivatives to do and log differentiation. So we have about 5 lessons left in derivatives. I've been pre-teaching you so that we can practice these a lot, because when I give just the notes, I lose everyone and they want to quit. So I figure it seems way less stressful if I just throw examples at you and you have to work through them, indirectly learning it but not really realizing you're learning it. See? All of mind game. Usually I have people cry. So I didn't feel like any tears were happening here. This is good. It's positive. Okay, so I'm going to give you some questions to work on. You're going to say this one. So if I give you this, I'm going to, there we go. If I give you y equals tan squared x, if I give you that, we don't have a derivative for tan squared x, right? We have a derivative for tan x, yes? Now, they will always write the squared in the middle between the tan and the x, because that means you have two tan x's, okay? If they put it on the end, that would mean you have a tan x squared, and you actually have two x's, not two tan x's. Do you know what I mean? So they give you this, or they give you this, that means you would have c tan x squared times 2x. Okay? This one means you have two tan x's. If you ever get the number in the middle, my suggestion to you, and by suggestion I mean do this, is to write it as tan x all squared, just like you have to put in your calculator. Remember when we had tan squared x's or something like that in your when we did like verifications and proofs and you wanted to check them? You would want to put in tan squared x. You couldn't go tan squared x because when you press the button on your calculator, a bracket opens up. Tan and a bracket opens up. You can't put the squared in between. So we had to write it as tan x all squared. Put it into our calculator. Same thing. So I'm going to rewrite this as y equals tan x squared. Then what is this? Starts with a C. Rhymes with chain rule. Chain rule. You guys are so smart. So, what would we get? 2 tan x to the 1, and then the derivative of tan x, which is secant squared x. Okay? All right.
What?
You're not getting a lesson this weekend, so zip it and do the question. You say I have rugby tonight? You have a whole weekend. Rugby tonight. You have rugby at 12:30 till like 2.